know me and some of the other co-authors, you immediately figured out I am neither Sarah Hodgson or Chris Ellings. I'm actually a pinch hitter. Neither one of Chris or Sarah could make it, and I wanted to recognize that they put a lot of time and effort into this process, as well as contributing to the written material. So just wanted to be sure they were on the list and in everybody's mind. And so because I was a pinch hitter, I felt like I could take a few hypothesis liberties. So that's not exactly the same hypothesis that you'll see in the written package. One of the big changes is I added quantity of habitat, because I thought that particular aspect wasn't really reflected in the hypothesis. So not real different, but just another thing to think about. And we've been talking about life history diversity, so here's my boxes and arrows effort to sort of look at life history diversity. And sort of a simple definition that I'd offer is it's just the variable pathways that fish from a, say, particular species or population follow to complete their life cycles. And there's a whole series of processes. You know, life history diversity doesn't necessarily just happen. It's a combination of genetics, location, environmental factors. Corey talked about once you have emergent fried, or maybe some abiotic and biotic factors that dictate whether the fish stay in fresh water or leave, or how long they stay in fresh water. But the point is you can sort of map these pathways, and I think Cy Simonstadt did this one time for Puget Sound Chinook and got like 48 different pathways. I'm not even sure he included residency in that. So Josh Chamberlain talked about residency yesterday. That's a form of life history diversity. So the point is, we're sort of talking about this nearshore and estuarine diversity. But one thing to point out is, probably with the exception of pink, where you tend to not see a lot of diversity, and maybe steelhead, but I think that's actually a question. But most of the diversity we see would be in terms of, say, Chinook and sockeye populations. And it continues once the fish enter, say, Puget Sound or the Sailor Sea, in terms of where they migrate, how long they're at sea. And so all that is the sort of different pathways fish can follow. Oh, and then one other thing. So if you're, depending on the side of the border you're on, you're either talking about yearlings or sub-yearlings or stream type or ocean type. One of the things to keep in mind is if you actually look at a number of, say, ocean-type populations, they will, some of the members of those populations will actually show up as yearlings. And in the case of some stream-type populations where you'd expect the fish to be yearlings, we'll often see sub-yearling fish in those populations as well. So like a lot of things with salmon, the world can be sort of a messy place. So I think there's a couple lines of evidence that I think we want to look at. First is we should ask the question, has the quantity, quality, and accessibility of nearshore habitat been reduced? And this is, if you like statistics and numbers, there's a whole bunch of stuff from a group called Puget Sound Nearshore Ecosystem Restoration Partnership online. There's more statistics than the Carter has killed. That dates me, because I know what that expression means. So I'm just going to look at a couple. This is the highlight or low light reel, depending on how you want to view it. So one of the things that struck me is the finding that the shoreline of Puget Sound is shorter and simpler. Basically, we have seen since the mid-1800s a decrease in the actual length of Puget Sound shoreline by 15%. That's a fairly dramatic change. The other thing we've seen is if you sort of chop the shoreline up into shore forms, and I think there's roughly, about 1,000 segments of Puget Sound, we've seen 366 natural shore forms have been converted to artificial ones, and we've also lost nearly 300 shore forms. So the shoreline is clearly simpler. We've also done things like, I was going to make it through the whole talk without doing one faux pas with the, there we go. So, shoreline has been heavily modified. Again, more statistics. There's almost 7 square kilometers of overwater structures in Puget Sound. 27% of the Puget Sound shoreline has been armored. And you can see situations like this where you just have a thicket of docks. The fish have to swim through that. What's the effect of that? Also, if you happen to have eelgrass or other prey production there, putting docks over that, especially at that scale, isn't necessarily a good thing. And in Puget Sound, a lot of the changes we see are these sort of small-scale things. This is an example of a change in quality. Yeah, the fish can still swim in there, but that used to be what we call a lagoonal system that's now a marina. So one of the more, depressing changes, I think, is the fact that in Puget Sound, if you look at the 16 largest deltas, and that's defined at about 200, actually I shouldn't say that. There's a fairly significant cutoff. But if you look at the 16 largest deltas, and that includes Skagit, Snohomish, Elwha, Dungeness, things like that, we've lost over half the wetland amount in square. And if you break that down, the most profound loss is this right here. We've lost almost 100% of the freshwater tidal and the Ligahaline wetlands in those systems. And one other little statistics here. If you look at the actual length of shoreline in these deltas, we've lost almost a quarter of that. And that's work from SciScience-Stat. In terms of habitat change, here's one that almost half of these small lagoonal systems, and Puget Sound used to be carpeted with them. Why they're important is we think they tie to one of the particular life history types. So we've seen almost half of those, or the length of those, lost. So then let's look at how habitat change has affected salmon diversity and behavior. And I'm going to look actually outside of Puget Sound. I think there's some really good stories in the Columbia River and Oregon coast I'm just going to pull in because we haven't talked about that very much. But here's one. This is some work from actually a fellow that was before his time, Willis Rich, in the 20s, and the Columbia River was actually determining that the estuary was an important place in the Columbia River system. And what he did was with scale analysis, and don't pay attention to the actual magnitude, but just the fact that you had all sorts of different types of fish coming through the estuary. So this is actually based on scale pattern analysis. And so Jen Burke, a student at OSU, in 2005, repeated this analysis under contemporary conditions and found pretty much an incredible simplification of the life history diversity in the Columbia River system. Most of these fish are hatchery fish, so the story is even a little bit worse. So at the same time that this has happened, we've seen almost 70% of the wetlands being lost, massive changes in fresh water, change in the hydrograph, change in the amount of floodplain area. So tremendous habitat changes accompanying that as well. Here's another story from Dan Bottom, Salmon River, Oregon. If you look on the right-hand side, look at this line right here. You see that in the 70s, there were almost no fish that outmigrated in the system before about July, and most of the outmigration was after this. Beginning in the early 70s, they started restoring all the wetlands in the Salmon River system. So by now, most of the wetlands have actually been restored, and this is what you see is now you see these early fry that are now showing up. We've seen changes in spawner distribution. And the other thing that's happened is people will say, well, these are all fry and they don't really contribute. 25% of the returning adults come from these early migrants. So not only did the wetlands restore juvenile life history diversity, they increased the diversity of the returning adult population. This is some work from Eric Deemer and Corey Green. Actually, Eric's name is down there. So the thing I want to draw your attention to is this upper graph. And while the wetlands have declined by about 50%, one of the things we've seen is that at a level of right now, at about 3,500 to 4,000 outmigrating smolt, we have reached the carrying capacity. So this basically shows that as you get more and more smolt, there's no place for them to go in the estuary. So we don't know whether this actually holds true in other systems in Puget Sound, I suspect it does in places like the Snohomish and Stillaguamish. But what we have is this sort of carrying capacity issue. So in order to get more delta fry rearing, we're going to need more habitat. And you can see one of the changes that also occurs is as you get into these higher densities, you get smaller fish. And the sort of final little storyline I'd offer is involving these pocket estuary systems. These are really complicated. They're created and maintained by all sorts of shorelines, geomorphic processes. But these early migrant fry really like to find them and rear in them. And you can see that evidence here. This is the fish that we see in these early in the year. They show up in these deltas. You see in some of these other types of habitats, we don't see these early fish. So, sorry, I'm going to cut you off just for 1 minute for having guests. Really? Was it that bad? I'm sorry. It was that bad. I thought I was at least going to get the hook, but... So, Laura, does this count against my time? Sure. Okay. I was going to make a joke about how the mute button on my remote is not going to get a rest since I don't have to mute all the political ads. But I like Paul's election day joke better. So let's try that one again. These are these small, what we call pocket estuary systems. They're non-natal. Chinook do not spawn in them. But these early migrant fry rear in them, and this is just to show that they're very complicated and how they're created and maintained. I'll pass through this and sort of go to, I took a little different view. We can list all sorts of research. I decided to give you my top 5. First, what are the linkages between habitat, quantity and quality, salmon performance, and population level responses? You know, it's one thing to see individual fish, occupying estuaries. What's the population level response? Are we seeing increases in the Skagit River Chinook as a result of some of the restoration we're making? How strong is the pocket estuary linkage in other parts of Puget Sound? We've seen it applying very strongly in the Whidbey Basin. I know Scott Stelzner has been working in the South Sound. It's implied in the Hood Canal. So I think this is really something we need to firm up. Shoreline habitat use is fairly remarkable that most of our focus has been on the large deltas. We don't fully understand what's the effect of shoreline armoring. We see it affect, say, spawning herring, and we link that to the later life stages of salmon, but we don't know what the effect on shoreline armoring on salmon prey production might be or migration. So I think there's a really rich need to research there. And I think this is one of the things that I've sort of come to the boat on in the last 5 years. I think we've really missed the boat with life history diversity in Coho. When I went to school, which I will not say when that was, the primary model was in Puget Sound, all Coho salmon migrated as yearling smolts, which was after about 18 years in fresh water. If you look now, sorry. I was afraid nobody was paying attention. So what we found is in a number of populations, we're producing fry, sub-yearlings that rear in estuaries, fall migrants, yearlings, and 2+ migrants. And in the Oregon coast, we're seeing these fry and sub-yearlings actually contributing to returning adult populations. And so finally, just a big broad question, what is the capacity of Puget Sound to support salmon? How many can we expect in there? And finally, some final thoughts. I think one of the places we can learn a whole lot about diversity and habitat is with restoration, because we're making some profound changes in like in the Squally Delta, the Stillaguamish, the Skagit, potentially the Nooksack. And by monitoring appropriately, I think we can look at the response at the individual salmon and population level. And because I'm a biologist, I want to throw in the pitch that the only models out there in the world are not physical process models. We also have biological models. And one of the things, this is is life cycle models. They can serve as a framework to put habitat use into the context of the whole life cycle. And I think really an exciting thing to consider is we might be able to link those life cycle models with physical models. Thank you.
Thanks, Chris. Next up, we have Sandy O'Neill, who will talk about the hypothesis that toxic contaminant inputs of imaging affecting marine survival of salmon through reductions in growth and resistance.
Good morning. Can you hear me? Do I need to be closer? Can you see it now? Okay. So if you can't hear me, just wave and I'll get closer to the mic, okay? So first I want to thank Lyndall Johnson, who's a co-author. She helped put together some of this material. I'm going to show you some old data and some new data, and hopefully I'll convince you that toxic contaminants are actually just another contributing factor to why we have poor marine survivals for salmon, particularly shrimp salmon and future salmon. So it's not the smoking gun that's a contributing factor. It's right up there with habitat degradation, predation, etc. So. Yes, I can. Oh, I can do that, can I? Yeah. See, I don't like to do this. I'm going to muck it up. Okay. No, that's okay. So Kurt gave a nice overview of some of the issues with habitat problems in the Sound, and certainly urbanization of the Salish Sea in general has caused all kinds of reductions, habitat loss and modifications for salmon. But when you think about anything to do with people and habitat modifications, you should also be thinking about contaminant inputs, because it is just one form of habitat quality. If you have a marina, you have contaminants coming off of that marina. If you've got a developed waterfront, you've got things coming off of that. Oh, sorry, I knew I was going to do that. Go back. Sorry. Okay. So the other big thing that is true in the area is that most of our urbanization is around the central basin, here in the main basin of Puget Sound. So all of our major cities are around here. We've got Everett, Seattle waterfront, right here we've got Commencement Bay on this side, and we've got Sinclair Inlet. So all of our big urban centers are right in the center of the Sound. And so it's really important that you keep that in mind, that you've got all this concentrated in one area. If you look at the figure on the right, you can see that all this red area is sort of impervious surface and development, whereas the rest of it is green. And you can see this is where it's all happening right here. So contaminants can affect salmon at three different sort of life history phases. They can get exposed. Contaminants can be in fresh water, because those contaminants that go into fresh water end up in marine waters. So you can get exposed in fresh water, you can get exposed in the nearshore marine waters, and you're out migrating as a juvenile. And plus some fish, as we talked about, stay in the Sound and you can get exposed at that point. I'm going to concentrate on the last two bullets. I just wanted to put up the freshwater one just to remind people that salmon can get exposed to contaminants in fresh water, and it can do things like affect its growth and disease resistance. And so that may have an effect, sort of a latent effect on marine survival. So I've put also underneath each of these which species I think are most likely to be affected. Within the write-up that we all did, this is outlined in more detail, so you can go and look at those, the appendices that you were sent online. But I'm going to concentrate mostly on the estuarine and the marine parts of Puget Sound, and I'm also going to limit this mostly to Chinook salmon, because that's where I think most of the problems are. This is our conceptual model, and I just wanted you to show that toxics is here, that you can get direct effects on individuals, and I'm going to show you in particular effects on health, disease, growth. Then you can also get indirects on habitat availability. And the big thing Dick keeps asking, why do things die? Well, they die for lots of reasons. And some of them are that they're in poor condition, they get eaten by predators, they don't compete well for food, they're more susceptible to diseases. Those diseases are worse in warm water conditions, so it's a very dynamic system. So I'm going to start with the marine waters. This is just to show you some data that the salmon and peach salmon, and juvenile salmon, Chinook salmon, are in all the urban centers have fairly elevated levels of PCBs. I'm only going to show you one contaminant for this whole talk because people don't like contaminants. They don't like to hear about all the letters. So, but I just want you to know that these are fish from that were collected in the yellow. We have some Puget Sound locations with the Duwamish and Snohomish on this end. These are some that were collected in the Columbia, coming down the lower Columbia. And these, I'm including lower river in this scenario because it's part of that's what we include in our concession model. These are some coastal populations outside of the Columbia, Puget Sound, Hood Canal. And so we're not seeing contaminants, so we don't have a lot of people there, there's not a lot of development. I just want to make one point that in addition to PCBs, which have been stable over the last 25 years based on monitoring other species, we have PAHs that have been increasing. Flame retardants have gone up, they're starting to go down. We have pharmaceuticals getting dumped into the system. So when you think of population growth, think of contaminants. So I'm going to show you two examples. One is a growth example. So these are some neat experiments that were done with Ed Casillas back in the mid-90s. I just don't think they got the attention that they would get now because we weren't focusing on marine survival to the extent that we are now. So I'm reviving. So they actually went out and collected juvenile salmon, Chinook salmon, in two estuaries. One in the Nisqually, which is pretty non-urban, and the other in the Green Duwamish. And they actually measured the factor in both the fish that they collected in the estuary as well as the fish that were in their companion hatcheries upstream. So this would have been, sorry, I meant to do laser again. So I'm just going to go back to it. So here you see, this is, I think, Sue's Creek in Clavis. Is that the hatchery on the Nisqually? So what you can see is that they have better growth, intellect growth factors in the non-urban setting. And when you measure the intellect growth factor in a Chinook in the estuary, it doesn't do as well. When you take them back into the lab and you actually just take those fish, bring them into the lab, and then measure them over time, you can see that in the Nisqually, you don't get much of a difference between the hatchery and the estuary for the growth, but in the urban center, there's a huge difference in the growth. There have been a whole bunch of other follow-up experiments where they've actually exposed them to contaminants in the lab and you get the same kind of reductions in growth. So it's something, it is a contaminant factor. There may be other things that are affecting growth, but the contaminants actually affect the growth. They've done similar studies for the hylobos as well. This is one other example now of immunosuppression. So this is actually part of the same study of, again, taking juvenile Chinook salmon from the Nisqually and the Duwamish estuaries with their associated upriver hatcheries. And Mary Arcouche took them into the laboratory and she exposed them to Vibrio, which is a natural pathogen we've just been hearing about. And you can see that the urban fish, the fish that are in from places like the Duwamish are more susceptible to disease. So it means that the contaminant is making this natural pathogen do more damage than it would do on its own. And this is a lot of the discussion that you heard in the previous session. Again, a contributing factor is one of the reasons it makes it worse. Sorry about that. Again, this was followed up additional experiments in the lab where they exposed them to different types of contaminants and were able to induce this same type of response in the lab. And again, it's been conducted in more than one estuary, like the hylobos and in other urban places like on the Columbia River. So the next one I'm going to just do briefly, because I'm running out of time, is the residency issue. And I wanted just to make the point, yesterday we had lots of discussions about the hydrology of Puget Sound, the Georgia Basin. It's basically a big bathtub, and so this is the ocean water coming in, the fresh water is going out on the surface. The big thing about Puget Sound, even more so than the Georgia Basin, is that the retention time of water is greater. It doesn't flush as great. So we always say that contaminants that get in the sound stay in the sound. They just don't get flushed out. Probably even more important than the hydrology is the biological isolation of Puget Sound. It's a deep inland fjord, and a lot of our species just don't leave Puget Sound. We have many resident species. We have resident herring populations, resident chinook populations. Our English sole populations don't leave. Our lingcod. It's a nice place to be. It's a little contaminated, but it's a nice place to be. So just to show you that this is actually a really big phenomenon, these are herring PCB data collected up and down the coast, all the way from the Queen Charlotte down to San Francisco Bay, and this is the amount of PCBs that are measured in the whole body. And you can see these go to about 50. Oh, shoot. I never do this, guys. Okay, there we go. So this is about 50. You can see that these are clean as a whistle. They get a little dirtier as you go to San Francisco. This is on the inside of Vancouver Island here. Look what happens when you go into central Puget Sound. The PCBs just pop up, and it's not that Puget Sound is more contaminated than San Francisco. San Francisco has just as many people as we do, but their herring don't stay in San Francisco. Our herrings stay here, and they make our food web more contaminated. And if you, one more example of that is these are contaminants in whole bodies of Chinook salmon that are coming back to spawn. Again, we collected them from the Sena, the Fraser Nipfish. These are South Thompson, upper and mid-Fraser. They don't include Harrison. So Harrison fish, I think, would be more like Puget Sound fish. In fact, I know they are. Peter Ross and I've measured the contaminant levels in the Harrison fish, Harrison Chinook. So what you're seeing is higher levels of PCBs in these animals, and it's because they're actually more resident in the sound. We think about 30 to 40, about 30% of them are resident, almost done, on average. And just to prove to you that I'm not making it up, we actually went and sampled some resident fish. These are fish that were collected in the fall of the year. There's a chum fishery at Apple Cove Point. Northwest Indian Fisheries guys are really great at holding on to them. So they're all sub-adult, and you can see they have way higher contaminant levels than those that out-migrate. So what you're seeing in this, the reason that Puget Sound fish are higher, it's a mixture of ocean migrants and residents, which bumps the overall average up. Okay, so that's sort of where we are. I don't really know what that is going to do in terms of health impact, but certainly in the winter, when those salmon lose their fat, all the contaminants then become more toxic because they get more concentrated in the fat tissue. So we may have reductions in marine survival of residents in that winter month. I'm a little over time, so I think I'll just stop. Just mention briefly, we've already done quite a bit of a literature review. We're pulling it together. We do have some ongoing monitoring. It's very piecemeal, but we do have some for salmon. The big thing that we have to do next is some of the modeling, and we've got lots of diagnostic studies, but we do need, in particular, more diagnostic studies. By that I mean, what are the thresholds that are associated with effects? We know disease resistance growth. We haven't really done a lot with floating and reproductive development. So, thank you.
Thanks, Sandy. Oh, you're great. That was great. All right, do we have feedback? Mark. Oh, wait, you're ahead of me. I don't have any more. Feedback on the hypothesis.
You might have your name. This is really interesting, and I was particularly interested in the comparative presentation here. So obviously there's a whole series of chemicals that have been done nowadays. Some of them are increasing. like the pharmaceuticals and others. But some others are probably decreasing. I suspect like DDT and PCBs are probably, hopefully, decreasing since they have been mostly banned, I guess, in many cases as well. So do you have any sense in terms of how the PCB concentrations have changed in either herring or shrimp salmon or other kind of seafood throughout?
So we don't have trend data. We don't have trend data for juvenile shrimp salmon or for adults, but we do have some trend data for other species, including herring. In general, PCBs sort of record peaks in the 70s, late 70s. They declined to the mid-80s. There's been very little decline since that time in the species count. So they're reduced. So what I showed you were current levels, so they haven't really gone down much in 5 years. There are some channels like CDEs that increase, although they're now starting to level off. We're starting to see declines in CDEs in herring. Other channels like CAHs, unless we get a replacement for a production engine, they're not going anywhere but up. The other thing is we don't now do a lot with a lot of these chemicals that mimic hormones, the xenoestrogens, the pharmaceuticals, and we're looking at additional funds to do that in the U.S. But those are very powerful studies that are So those things, our bases are going to be highly correlated with population growth. So those are going to be on the top. So there are things like metals that have definitely gone down, but I would say there's probably a general uptick in most of them in the basis. People down being working.
So I've got Kip and then Terry and then Dave.
So my question again is, of course, now we're seeing these toxin impact at the trophic levels, which is found in orchids. Do we have any historic research on how those toxins impact my overarching theme at this conference, which is primary productivity and secondary productivity? How does that affect Christopher's 13% reduction in chlorophyll, plankton, zooplankton? Do we have any of that? And if we don't, we need it. So that's on my wish list.
Okay. Great. Terry?
The PCBs, we obviously have some rules that kind of stop the use, but it appears that there's a lot of it still in the landscape, still on the landscape, and likely to be there for a long period of time. As you're looking at that and the impact to the fish, especially in central Puget Sound, is there any schedule as to how long these PCBs are going to be prevalent and available for the fish, or where are we now in trying to understand how to eliminate that?
The partnership in Department of Ecology in particular is really looking a lot at ways to reduce contaminant inputs to the sound. So a lot of their emphasis is on figuring out where they're coming in, from what pathway in the stormwater, PCBs in the building that they can run off the answer. Is it getting resuspended from sediment? Is it coming out of our wastewater treatment? So they're looking at different pathways for PCBs and they do have estimates about the current loading. I think their loading estimates are low because they're saying that with natural attenuation, meaning do nothing, by 2020, these PCB levels should, if liquid sediment should go away because most of the surface water running into the sound coming off of forested land, and there's hardly any PCBs in forested land. I think that the stable of their model or the granularity of their model is not declining enough because they're not picking up this, but we're not even seeing decline in the controls of them. So it's probably on the order of, it depends on the loading. It's also on the loading. I don't know what the loading is, but it's more than what they're modeling at the moment. So it's going to be a while for us.
Thank you. Dave and then Alex. Am I missing anyone?
Thanks. With respect to the estuaries question, I was really happy to see that, and there's been some recent developments on the VC side, which may be kind of encouraging for people interested in that. And one of those is there's two things that have begun to happen with estuaries, which may compel or at least encourage governments to become more interested in this. And one is some folks are probably familiar with the fact that there's been increasing interest in the use of estuaries as carbon sequestration. And in Canada, municipalities are actually going to become compelled to come up with a carbon balancing plan. And this may be one way to drive their interest. The second thing is as a use as a bulwark insurance, if you will, against sea level rise by developing salt marshes and these sorts of areas. So there may be other reasons which may be allied to, say, more salmon-focused biological interest to create a synergy there. And certainly programs in San Francisco Bay and Mississippi Delta have begun to set up the way to establish the economic and biological baseline for which you can establish that. So that may be a good thing for folks here to explore who are interested in figuring out how we can leverage this estuary issue to some of our past questions.
Great. Good idea.
Just the rock star one here. I mean, one of the more remarkable habitat types that I think exists are wetlands. I mean, their functions go way beyond just making salmon, and they're really incredible systems. And as I said, the striking loss in Puget Sound is that we've almost lost the entire block of oligochaetan wetlands that existed in all these large deltas. And you know, it's hard for me to believe, even if you just take the salmon story out, that's sort of a trivial impact. It's a trivial event. So I think all the ammunition you can bring to bear on sort of protecting and restoring these wetlands would be immense.
Alex?
Yeah, I would like to be away without answering a question about PSNR. A lot of the analysis showed that you have these large barriers in terms of Commencement Bay, Elliott Bay, and even in Bellingham Bay. How do you put a cost-effective, how do you develop a cost-effective way to regain any or all of the habitat that's lost to those types of development? And understand what is chewing with you.
So we'll use one microphone. You know, I think that sounds too pessimistic, but I think there are places that are so profoundly affected and damaged, like Elliott Bay, that I'm not sure there's a cost-effective way of dealing with them in the future, and I'm not sure, given limited resources, that's the best place for us to put our money, at least now. I guess my strategy with those sorts of systems would be to try to keep them from getting any worse than they are, and hopefully over time we've developed some technological approaches to addressing places like Commencement Bay or Bellingham Bay and Elliott Bay. I think there's a lot of great things to be done in some of the other delta systems, including those in British Columbia, and part of me is concerned that those large urban systems, because that's where people live, that's where you have the political power, almost become distracting.
If the toxic levels are high enough, I don't think that that's happening. I think they're more susceptible to or like video. They die. It's anything that dies different. So you don't see a lot of dead bodies. The only place you actually see dead bodies are like on coho.
Okay. So, any more quick feedback on our hypotheses? I heard from Kip Gravity and the effect of contamination on primary places. Any other feedback on those?
So I'll add something here. We didn't have any Canadian presenters on this section. From side conversations with Brian, there wasn't much to go on. Correct me if I'm wrong here, on contaminants for at least what you guys have done so far. So is there something, is that a gap that needs to be filled? I don't think that's quite what I said, but it is relevant. We have trouble finding the actual data. My immediate concern now is for the future because many of you will have heard that there are 3 extremely good quality contaminant labs in Canada that were all put together in various departments. One of them was at the Institute of Ocean Sciences in Sydney. And the Department of Fisheries and Ocean has announced that they're getting out toxicology and contaminants work. So I hope they're going to use those equipment. But that lab and those people, including some very prominent scientists working in these fields, are no longer going to be in the department. So we need to find a place that is going to do this work. It's to go to Environment Canada, and Environment Canada says they don't have the money to do it, so who knows? So a real question to you would be, do you have lab capacity to take on some of these other sample processing and so on? Because that is a logistic issue that we're going to have to address. And before you answer that, let me make a comment on irrelevant to the first table he brought, which is the same sort of thing that we've been looking around the Strait of Georgia. And in the Fraser River, I think it's commonly acknowledged now that we've lost 85% of all types of wetlands in the lower Fraser. There is a new development in the port which will take another large chunk of property for port expansion, and that's actually directly in the estuary. So it continues to really be an issue. I don't think that Dave's comment about the smaller estuaries around the Strait of Georgia is relevant. It's definitely going to assist in the diversity of populations and productivity in the smaller systems. But the Port of Vancouver clearly has an interest in this, and so we really need to be working with them. Now, that is a federal agency that has accountability for the land from pretty much, I think, Mission downstream and around in the Indian Arm and Squamish area. So it's a really important group to be working with nowadays. But in the lower Fraser, it's a serious issue. And I expect that the wetland area laws could actually be comparable to all of Puget Sound area. And because there are massive wetlands in the lower Fraser. And of course, the other aspect is much like the lower Columbia, the lower Fraser is totally dead. So there's no easy recovery of wetlands in the lower Fraser.
Sandra, did you want to respond to that comment, and then Sophia wanted to add?
So I think the question was, Brian, is there capacity on this side to work with, like, gear rock? So, in fact, Peter just called a project that Department of Environment wants to do some contaminant studies on salmon. So we are trying to do that in conjunction with him at our lab. We're also getting close to capacity. So it's we try. So yeah, but I think it's going to be a real challenge. Can I make a comment?
Yes.
This is a contaminant issue. I think it's great that we try to restore it. That they will come and protect the strongholds we have. But I think the corollary is also true. If you pollute, they will perish. And even places like the Macquarie that was restored, and they're wonderful, restoration projects, those fish still have to swim the length of Puget Sound, and they have to get out through all that contamination in the central part of the sound. So I think we have to be mindful of those.
Thank you. So you're the other one. Okay. Sophie?
NOAA actually has quite a lot of contaminant data for the state of Georgia as well. Sediment data and killer whales and seals and fish. We've also done 2 basket studies about what the seals are eating, if it's the concentrations of contaminants of different kinds in the specific species. We've been doing quite a lot of this work, and some of our work goes instrumental in helping to get the latest batch of flame retardants from Canada. But that work will no longer be continuing. I just wanted to emphasize what Brian said, the profound nature of the cuts to the contaminant research in Canada. It wasn't just reducing the amount of money. The contaminant program was completely eliminated nationally, and everybody who was being to spend more than 50% of their time studying contaminants got laid off with it. That was my colleagues in my hallway. There are only 2 of us left because we were felt for less than 50% of our time on contaminants. And since CFO was doing almost all the marine contaminants work in Canada, there are a couple of other university scientists, but we were doing almost all of it. That's just not happening anymore in Canada.
I had Nate and then Josh and then Mark, and then we should probably try to wrap up.
Yeah, I was just curious about if the data is good enough and the understanding is good enough to identify the history of the contaminant loads in the Salish Sea and where you might start crossing some ecologically significant thresholds if there are any, or is that really hard to puzzle out? And I'm just thinking about, you had the graphic that showed contaminant loads in salmon and then some other species at Georgia Basin versus Puget Sound. They're quite different. But some of the other indicators we've looked at, like the marine survival rate, crashing, maybe earlier in Georgia Basin than they did in Puget Sound, but at least in the 80s at the time.
PCBs have a decline since the 80s. They usually look at contaminant trends with sediment profiles, so they use core samples, and one contaminant doesn't work independently, so there's always some mixture of chemicals out there. And so I know they looked at like pH is increased, and then it drops off with the cold, and then it got rid of cold, and it was slowly increasing again. PCBs are definitely stabilized and haven't gone down since about the 80s. I don't know that I've seen enough to say that the decline in shrimp in Puget Sound is any worse or better than St. Georgia. I'm not sure. But when we're looking at catch data, we're not looking at actual abundance data. So I don't know that that is true. That the St. Georgia is worse in terms of the catch.
Well, the marine survival rate data.
Sorry?
The marine survival rate data is more clearly looking at that part of the life cycle.
So the marine survival data is definitely worse than the St. Georgia. Yes, the trends are the same. But again, the Harrison shift, for example, you also regard as down and have contaminant levels of other populations. I don't think the contaminants are an issue for the sockeye at all. And I don't think they're an issue for fish. So we should have just removed and keep it with. Things like you might get someone in freshwater, but I don't think that that's a good issue. So really, it's mostly a issue.
We got Josh and then Corey, and then we should.
Real quick question.
Okay.
Harrison has now come up 3 times about being in Puget Sound, and they are. But let's not overly generalize this, because the proportion of Harrison in Puget Sound is likely about 5% of the abundance. Right? We have quarter-wave tags going back to 1981 and large tagging rates and that. So they're not down there in great abundance, but they're present.
Right. The Puget Sound fish that are resident aren't necessarily resident in Puget Sound the whole time. They have a more local distribution. We think of them as being actually a route migrant, so they're in and around the Central Basin. They might go off to the Strait of Waterkeeper and come back inside. Ernie Taylor had some stacking studies from UW where he was looking at recovery over time, and he would see ships that were actually going out to the Strait of Waterkeeper, the West Coast, and coming back into Puget Sound in the winter months. If you look at the stable isotope signatures for Harrison ship, and the stable isotope signatures tell you what surface level you're feeding at, but also how near shore you are. So look at the carbon. The carbon signatures for the delta C for carbon, in Harrison fully match those for future samples. So they overlap a lot. And Peter Ross has mentioned the comparative levels, and the averages for Harrison Chinook are 50 parts per billion for PCBs, which is exactly the average for his sample sizes.
So quickly respond and then we need to...
Quickly responding.
Yeah.
I'm not sure that you can equate that to being in cubic channel. I mean, they're similar to cubic channel in distribution because we've long known that Harrison are through the Strait of Georgia and West Coast, Vancouver Island, West Coast, Washington. They're not far north migrators. They're quite a local stock of Chinook. That's one of the things that makes them unique. Exactly. They have the same sort of ocean distribution, but it's not just the fact that they're in Puget Channel, but there is some small portion of them there.
When I say residency, that residency signal was resident in the state of sea, so I came up with my estimate based on the catches through the crab line. So those are estimates for Puget Sound. I don't know what they do for Harrison, but they would include catches inside the state of sea, including the closest Vancouver.
I think we're at the end here, so I'm just going to ask a question to think about for the session this afternoon, and that is, how would you operationalize the study of the impact of toxics on juvenile salmon and the impact of habitat, estuarine and nearshore habitat limiting juvenile salmon? What would be the experiment, or what would be the microcosm or mesocosm studies, or what would be the modeling, so that we could incorporate that? I mean, it looks like there may be, you're suggesting an interaction between toxics and disease. So there may be some interaction between disease and nutrition. So how would we, I'm thinking, as we try to prioritize our actions and come out of this with a proposed set of research studies, I don't think, probably don't have time now to talk about this, but as this afternoon, that's where I'd like to go with this.
Okay. Great. Corey?
Looking at number 3, I'd just like to make a plug for Rusty 3D survey through Puget Sound. You need samples of basically any salmon species, well, mostly Chinook chub, pink, and coho, and herring, and you look interested in disease ecology or contaminants. There's a bunch of samples you collected throughout the time.
Great. Thanks, Corey. Okay, so what I'm hearing, just very briefly, these are very interesting hypotheses. It sounds like coordination on the contamination hypothesis will be crucial because there is very little capacity left in Canada to do this work. Didn't talk a lot about the habitat hypothesis. These also seem like things that could be coordinated across the boundary with some benefit. Is that right, Chris?
Yeah, I wanted to suggest that listening to Sandy, I sort of found some strong parallels between the contaminants and the habitat issues, and in part, I think we're really good at documenting things that are wrong. I mean, we know lots of levels of contaminants. I can give you chapter and verse on all sorts of things wrong in Puget Sound, and we probably have similar data. What we're not particularly good at is converting those sorts of information into, I guess, effects. What are really the impact at all different scales of these sorts of changes? And it seems like that, for both of these hypotheses, that might be the real key thing. Not, Sandy, I think, has shown there's some fairly hideous things in the fish that Buzz Holling is probably trying to catch out there. So I think there's some ways you might think of both these hypotheses in parallel.
Okay, great. That's very helpful. All right. Thank you very much, Chris and Sandy. That was great. Thank you all for the conversation. And now